Now we will see question number 7. If the position vector A of the point 5, n is such that modulus A equal to 13, find the value of n. We have been given here vector A is equal to this 5, n means 5i cap plus nj cap. And we know that if there is a vector A equal to ai cap plus bj cap plus ck cap, then modulus A is given by under root of a square plus b square plus c square. So here vector A is given as 5, n means 5i cap plus nj cap. Modulus A will be equal to under root of 5 square plus n square. And since modulus A is given as 13, so this implies 13 is equal to under root of, simplify it, 25 plus n square. Find the value of n from this equation. Square both the sides. So 169 is equal to 25 plus n square. That gives us n square equal to 169 minus 25. This is equal to 144, and therefore n equal to plus minus 12. Root 144 is plus minus 12. So rest work is simple algebra. We find the value of n as plus minus 12. Important thing here is that if vector A is given as ai cap plus bj cap plus ck cap, then modulus A is given by under root of a square plus b square plus c square. This we should remember. Now we will see the next question. Question number 8. If vector A and vector B are position vectors of points 1, -1 and -2, m, find the value of m for which vector A and vector B are collinear. See, we have been given vector A equal to 1, -1 means in vector form it can be written as 1i cap plus -1 j cap. That is, it can be written I cap minus j cap. Similarly, vector B can be written, since it is -2, m, so it can be written -2i cap plus mj cap. Now, when A and B are collinear, then one vector can be written as lambda times of another vector. So we have been given A and B are collinear, then we have to find the value of m. When A and B vectors are collinear, then vector A will be equal to lambda times of vector B. This is the condition which we have seen. So that gives us, this implies that I cap minus j cap equal to lambda times of -2i cap plus mj cap. A and B, we have put the value of A vector is I cap minus j cap, and value of B vector is -2i cap plus mj cap. Comparing both the sides, the coefficients of I and j, we obtain 1 equal to -2 lambda. When we compare the coefficients of I, we obtain 1 equal to -2 lambda, and when we compare the coefficients of j cap, we obtain -1 equal to lambda times of m. Now this gives us lambda value equal to -1/2, and here we obtain m equal to -1/lambda. Now lambda value is -1/2, so therefore m will be equal to -1 upon the value of lambda is minus 1 by 2. Minus 1 by 2, which gives us m value as m equal to 2. So value of m will be equal to 2, for which the vector A and vector B will be collinear.